I saved number 11 for its own video because it has something in it that none of the other problems have had. And namely, we have this sine of x over x in here. We've got a 9 and a 5 in here, of course. But when x is approaching 0, we get 9 times the sine of 0. So we always try replacing x with 0, and then we get 5 times 0. Now, we know that the sine of 0 is 0. And then we get, so in the numerator, we get 9 times 0, which is 0. And then we also, in the denominator, get 0, 5 times 0. So again, this is our indeterminate form. When we get that, we have to do something. That's our kind of cue to make sure we do something. We don't just stop and say 0. This is, again, we don't know what the limit is, and we don't even know if there is a limit. So here's what we do with this one. We take the 9. We're going to use the property, the limit as x approaches a, of, let's say, some constant times f of x. The property is that we can factor that constant out to the front, and we can multiply it by the limit as x approaches whatever of f of x. So we're going to do that here. So notice we can take the 9 and the 5 out. So this limit here becomes 9 over 5 times the limit as x approaches 0 of the sine of x over x. Now, this is the only one that I'm going to ask you to memorize. Okay, so this is a very specific limit, and I'll tell you why in a moment. This limit has a value of 1. If you look at the graph of sine of x over x, it would look something like this. It doesn't exist at 0, but the limit, let me see, let me use green here. So at 1, we have a hole in the graph, and then it kind of comes down like that, and it goes back and forth over the x-axis, and it comes down like that, and it goes back and forth. So you wouldn't know this by anything that you've learned already, but if you did graph this function on a calculator, you would see that. So if we evaluated this limit numerically, so if we punched it into our calculator and looked at the table, we would see that the y values keep getting closer and closer to 1 as x gets closer and closer to 0. And so, again, that's the thing we want to make sure we remember. The function does not have to exist at wherever x is approaching. All it has to do is be going towards the same y value from both sides. And so that's what this one does. So this is a very specific limit that comes up from time to time. And so I want you to memorize it. This limit is 1. And so therefore we get, in the end here, we get 9/5 times 1. So the limit is 9/5.